All right, so today we're going to continue, probably conclude with encapsulation. Remember that encapsulation involved, in C at least, it involves creating structures. And by encapsulation, we mean actually three things, of which C only really supports one. The grouping of data, the protection of data, and the grouping of functionality that acts on that data. And with respect to structures in C, we're going to be focusing on the first one there. Now, there are ways that you can achieve kind of the second two, but they're kind of hackish ways of doing it, and we won't focus on that. Remember that we went through this demonstration where we created a couple of structures here. The first structure was to model a date, which we modeled after three numbers: a month, a day, and a year. And then we used that as using composition, because a structure can be composed of other structures. We created a structure to model a faculty member. In this case, we've got a first name, last name, an NUID, and then their address: city, state, office, height in meters, and then their hire date. Right? And we went through a bunch of activities. We noted the coding style that we used here. But then we went through a bunch of activities for creating a factory method to create instances of a structure. We went and did a destructor. We suggested that we would also have a general two-style string here, two-style string function to convert our structure into a human-readable string format. So that's where I wanted to pick it up. Let's go ahead and continue with that designing of this structure here. Okay. So first of all, remember that free faculty, that was our destructor kind of function that took a faculty member, took a faculty structure, and then freed up everything that was allocated to it. What did that look like again? Well, to free up a faculty, you need to free up their first name and their last name, and then you can free the faculty itself. Right? If you didn't do these first two things, we observed by running Valgrind that you would end up having a memory leak. Okay? And so we went back and we fixed that. Again, to-do documentation here. We also, before that, we had this create faculty that, given all these pieces of data, dynamically created a structure and then returned a pointer to that dynamically allocated structure. What I want to do is, as our next function that we'll write here, is instead what I want to show you is an init style, initialization style function. What I mean by that is what we'll do is we won't return a structure. Instead, what we'll do is we'll give a structure to this function and tell it, please initialize everything for me. Right? In other words, it's going to be exactly like the create faculty function up here that'll take up all of these things, but instead of dynamically allocating a new structure, it'll also take a pre-existing structure and simply initialize everything with it. Okay? So let me go ahead and cut and paste all of this stuff. And I'm going to call it, we're not going to return a faculty structure anymore, so we'll just return void, and I will call it init faculty instead. Init, short for initialize. Okay? And we're going to take all the same things that we took with the create faculty function up here. But also, we're going to take a faculty by reference. Faculty, I've got to spell it correctly. There we go. F. Now, I'm not making that constant because I am going to be making changes to it. I'm going to be setting its first name, setting its last name, setting its NUID, etc. But the key difference between these two functions is, does the faculty structure already exist, in which case you're just going to initialize its elements, or does it not exist and you want me to create it for you? Right? So why would you do both of these? Well, for flexibility, right? Flexibility of design. So let's go ahead and implement this function now. I'm going to cut and paste this over in faculty.c. In fact, I'm going to do it right after create faculty here because we're probably going to want to steal a lot of that code. Right? And then think of a better way instead of stealing that code. Right? So what would this look like? Well, the faculty member already exists here, so we don't have to create it. Since it exists, what we can do is we can set its first name, making a deep string copy function here. It set its last name, again, deep copy of a string. Its NUID, height, etc., etc., etc. So copy, paste, that entire block of code there. Right? What was my first mistake? Should we ever copy pasta? Right? If you have a chunk of code here and then the exact same chunk of code up here, right, what is that screaming out to you? Red flag, red flag, red flag. Should you have repeated code like that? Nope. DRY, the DRY principle. Do not repeat yourself. Right? Okay, so how can we improve this? Return. Right? Again, I am making changes to this F right here. Okay? So I've got a repeated chunk of code here and a repeated chunk of code here. Maybe one of these functions should be calling the other function. Which one should call the other one? We've got create faculty and we've got init faculty. Init faculty assumes that that faculty has already been created. Create faculty has already, or is not going to assume that it's already created and will create it for you. Which one should call which one? Initialize calls create. If we did that, what would it look like? I would say faculty F is equal to, and then call create faculty, dot, 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 right? Well, now I've got two faculty, right? F already existed, right? So why are we creating F2 or something like that? Right? What about the other way around? What would it look like if this one called the other one? It is our responsibility to create it and initialize it. Well, we've got a function to do that second part, right? Once we've created it, we can simply just call init faculty, passing on the pre-created faculty structure along with everything else. First name, last name, NUID, height, meters, what else is there? Year of hire, copy, month of hire, and day of hire. Right? Much cleaner code, right? Create the faculty member, initialize it by doing this chunk down here. Okay? And then we simply return from that init faculty, and we return the created, dynamically created faculty here. Okay? Dynamically created structure. It doesn't matter if it's faculty. If it's, I think in the videos, the tutorial videos we do, like students. In your hack this Friday, you will be doing airports. I think, and in your lab this Friday, you'll be doing RSS feeds, right? And whatever, anytime that you have multiple pieces of data that define one thing, that is screaming out to you, define a structure to hold that stuff, right? The second that you have two pieces of data that belong together, group them, okay? Two or more. All right, so that was we did a destructor, we did an initialization function, right? Now let's go ahead and do a function to print a structure as a human readable format. But what I'm going to do is I'm going to start out by simply just creating a function that will convert this person into a string, right? A string representation. So let me go ahead and create the header, or create the prototype over here. Right? We're going to be returning a string, and what is a string in C? Char, is that it? Char star, right? Faculty to string, right? And it's going to take a faculty member, faculty star F. Now, am I going to be making changes to that structure? Probably not if you're just converting it to a string. So let's make it const. Okay. Again, to do documentation here. All right. With that faculty, let's go ahead and just print. We can take all their pieces of data and we could convert it to a JSON format. We could convert it to an XML format. We could convert it to a CSV format. I'm going to go ahead and convert this to a tabular format, right? If you were to print this out to the standard output, you would have a column with all the first names, a column with all the last names, a column, a column, a column, a column, right? So let's go ahead and let's not do all the pieces of data. Let's just do a few pieces of data. Say the last name, the first name, their NUID, and then their date of hire, right? So we can document that. right, it will returns a string representation of the given faculty member, faculty structure, which includes their, which has the format, in the format, last name, comma, first name, and then maybe in parentheses here, their NUID, and then their hire date, right? Year, month, day, right? This is their hire date. So we're going to go for that, that formatting right there, okay? So help me out. I want that kind of formatting. If I were to use printf, it'd be pretty easy, right? It'd be %s for the last name, comma, %s for the first name, space, and then in parentheses, if I wanted to format an NUID, and NUID is an integer, isn't it? How did we define that? Yep, it's an integer, okay? So if it's an integer, it'd be %d, right? And then we can also end the line if you want to, but I'm not going to. I'll let you, here's a string format. If you want to end the line, go ahead. Otherwise, that's up to you. I'll leave that up to you, right? And then what about the date of hire? Well, that's 3 numbers, right? %d, and then hyphen, %d, hyphen, %d. That's the year, the month, and the day, okay? And how do I go about printing each one of those things? F, and then I need their last name. How do I connect that? F's last name, right? Can I do it like that? No. What are the 2 operators that we've studied so far? The arrow operator, and the other one is the dot operator. Is the dot operator correct in this case? I've got a pointer to a structure, right? If I've got a pointer to a structure, what do I need to do? Dereference inside parentheses, and then I can use the dot operator. So it's not the dot operator. It'd be something, if I wanted to do the dot operator, it'd be something like this, right? That's ugly. What do we like better? Arrow operator, because it's a pointer. All of these things will be the arrow operator. First name, F's, NUID, and then for each one of the other parts, the year of hire, the day of hire, and the month of hire, or switch those last 2 around, I have to go back and see how I created this. Hire date. But date, is that a regular old structure, or is that a structure pointer? If it were a structure pointer, it would look like that. So it's a regular old structure, and I do use the dot operator here, right? So F's hire date dot year, F's hire date dot month. Was it day, month, year? Yeah, month, day, year. There we go. And then F's hire date dot day. There we go. And that's printf. Right? Is that going to return a string though? Nope. All right. Well, I'd like to bring printf style, stuff to bear here. I don't want to have to reinvent the wheel. So how could I use printf instead, the functionality of printf, but instead of printing to the standard output, I print to what I want to return, a string here. If I want to print to a file, what do I use? What are you using right now, hopefully? fprintf. If you want to print to a string, what do you use? sprintf. Exactly, right? And how do I do that? Char, I'll call it a buffer initially. I'll just create it large enough to hold any last name, first name, NUID, et cetera, et cetera, et cetera. And I'll pass in this buffer here, and then I'll try to return the buffer. There we go. Now, is that going to work? What kind of string creation is this? Is this static or is this dynamic? It's static. And what is the thing about static declarations? Where are they declared? In the stack. Static, stack. Dynamic, heap. Right? So, function calls function calls function. When that function returns, what happens to everything in that stack frame? it gets murdered, deleted, right? So am I going to be able to return this buffer? Nope. In fact, let's find out if the compiler can call us out on this. WAL flag, NG, just in case. Faculty, and then I'm just compiling the first part here, so faculty.c. There we go. Okay, well, I didn't include printf, so I need to include, stdio, there. So I need to include the standard input-output library now that I'm using something in it. Let's try that again. There we go. Function returns an address of a local variable. Right? It is warning us that you cannot do this because it will disappear, it'll be murdered when the stack frame is popped off the stack. Right? Fine. Solution 2. I can't do static. So the other option is dynamic, right? Now, if I want to be safe about this, I could, go through and nitty-gritty, count up how many characters are in the last name, how many characters are in the first name. An NUID has 8 characters. A year has 4 characters. Sorry about that. Spam. It was face down. Face down should be in ignore mode, right? My phone's too old for face down mode, whatever. Higher data than month would be 2, then day would be 2, and then all that punctuation in there, right? 1, 2, 3, 4, 5, 6, 7, 8, and then 9 for the null terminating character, right? If you wanted to be that exact, what would you end up doing? What would it end up looking like? Int n is equal to strlen of the last name plus strlen of the first name plus, and then there are 8 characters or 8 digits in an NUID, plus 4 for the year, plus 2 for the month, plus 2 for the day, plus, and then I have to go through 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So 8, and then I'll add 1 for the null terminating character. Lots and lots of math, lots and lots of magic numbers. What do those numbers correspond to at this point? Well, you could create 1, 2, 3, 4, 5, 6 more variables and give them names, right? And then you would be very, very exact on all this stuff. Does anybody like that idea? No. It's very brittle, right? You'd have to go, if you wanted to change the formatting, you have to make sure and go back and change each one of these numbers, right? So, all right, fine. I will have a temporary buffer. In fact, I will call it such, temp. 1,000 characters is not going to kill anybody, right? That's less than 1 kilobyte. Right? I will print it to the buffer, but after I've formatted it, now I can easily call strlen on one result. Int n is equal to strlen of buffer. Right? That'll automatically put in the null terminating character for me. It'll automatically format all of this stuff nicely. Right? And then what I can do is create a dynamically allocated string. Char star result is equal to char star, call to malloc, size of char, right? Number of bytes that a character takes, times n. Then I can do a deep string copy into result, buffer, and then I will return the result instead of the buffer. Right. Now there is a mistake here. What is it? Yeah.
+1 on the allocation.
Always remember +1, +1, +1, +1. Strings +1, string +1, all right? Just ram it through your head because that is the most common error. That is the most common error that we saw on the last hack, not taking care of the null terminating character. strcpy will take care of it for you. sprintf will take care of it for you as well. But you have to make sure that you are allocating enough space so that it fits in there. Right. I'm also going to get rid of one line now and just put in strlen. And again, these 2 lines of code, I have now repeated these about 24 times at this point. What should I have been doing this entire time? Put it in a function, put it in a function, put it in a function. Okay. All right, let's try to compile that again. Oh, I renamed it temp, sorry. So that should be temp, temp, temp everywhere. There we go. All right. Excellent. Let's test our, before I free up the faculty, let's test our functionality here. So char s is equal to me, or what was it? Faculty to string of me, right? And then we can print it out, printf %s. Here I will end the line so that I can go to the next line to print the next faculty member, okay? And I will print out s, right? And then I'll go ahead and go with s is equal to faculty to string of Grace Hopper there. And then I'll print her out. Right. This is just for ad hoc testing, so it's okay. But I do have a memory leak here, don't I? Where? I've got a string representing me that I print out, and then I should free up, right? Free s. Right. Now I don't have a memory leak on the first string, but I have a memory leak on the second string, and so freeing that up will ensure that there are no memory leaks here. Right? Again, it's not that important when you've got a demonstration or just an ad hoc testing function kind of like this. But it will eliminate any error messages that you get from Valgrind that you might be having, and then you have to isolate the actual errors somewhere else. Okay. Let's go ahead and compile all of this together with the wall flag, demo.c and faculty.o. There we go. No warnings. We run it and we see, hello, Chris and Grace. There I am, Burke, Chris. 8 characters here. Ah, that doesn't look like a nice, well-formatted hire date to me. Not only that, but if I had leading, how many? I think one person had leading zeros in their NUID. Right? If it was 0, 0, 1, 2, 3, 4, 5, 6. Right? What would it look like? Let's compile that again. And there, I'm not getting those leading zeros as a consequence of my design decision to model an NUID as an integer. And believe me, these things matter. We've had bugs on both campuses at several points where one system will assume that it's represented as a string and that those leading zeros are there and do string comparisons to see, is this the person with this NUID? And other systems will assume that it's an integer, and so we'll drop those leading zeros and try to do an integer comparison. Right? And then you can't check out books or something like that. Right? So how do we go about solving this issue? Let's go back over here to faculty C. Now remember that you can use modifiers. That will print at least 8 columns. So let me go ahead and recompile this and show you what I mean by that. Right? This is the exact same thing that you've used before on, say, printf with %f. Right? And you'll see here that when I run this, now I've got those leading spaces. Right? But that's not what I wanted. What I wanted was leading zeros. Well, here's another trick. If you put a 0 in front of it, it'll pad it out with zeros instead of spaces. Likewise, for the year, if I always want to ensure that there are going to be 4 digits, pad it out with zeros. If you were hired in, say, 900 AD or something like that. But it'll be more important, of course, with the day and the month, where we have leading zeros, so that right now it's, or not right now, but like the 9th would be 09, July would be 07, and the 1st would be 01. Let's go ahead and recompile that, and recompile that one, and run it again, and I'll show you now that everything is perfectly aligned. Right? The last name and the first name, of course, that's only because we have exactly the same number of characters. If you had somebody with a different length name and you wanted to align everything up, you could still do that by, say, I don't know, 25 and 25 or something. Right? Now, of course, yeah, we made it big enough to hold that, so we can get away with that. I think. Yep, there we go. Maybe 25 is too much, right? Not only that, but there's the 25, 25 minus 6, 19 leading spaces. I don't want that. I want it aligned to the other side. I want it aligned to left. How do you think I could do that? We'll go ahead and kick it down to 15 here. But by default, it's going to be aligned right. For positive numbers, if you want to, you can get it to be aligned left with a negative value. I'll go ahead and eliminate these, the comma here, and minus 15 here. Not many last names and first names are more than 15 characters, so I think that we're good here. Right? Oops. There we go. And then, nope, come on, there we go. Then we can do it, then we can run it. There. Very nice if you wanted to get this into a ledger style. Okay. All right. Let's do some more practice here. Other convenience functions, you can do similar functions for arrays of structures. Well, to do that, of course, we need to talk about arrays of structures first. So how do you get an array of integers? An array of integers is int star, right? An array of doubles would be double star. So an array of structures would be whatever the structure name is, faculty, and then star, right? Faculty. Right? It's the same word as pluralized here, right? So we could call it department faculty instead, just to drive home the point that those are two different things. Right? Well, when you have an array of integers, what else do you have to keep track of? Just as with an array of anything, you have to keep track of its size, right? So if you're going to pass this off to a function, you need to tell that function how many faculty are in there. If you're going to pass that off to, or return that from a function or something, or call malloc or something like that, you definitely need to make sure that you are passing that off and that you're doing the bookkeeping, okay? All right, let's go back over here to demo. And let me create two more, Grace, Joe, and Jane. There we go. Joe Smith and Jane Smith. There we go. And I'll go ahead and give them 1, 2, 3, 4, and 5, 6, 7, 8, 1956, and say 2004. Actually, no, 2016, October 3rd, I think it was. What's the significance of that date? When Harambe. No. I think it was on the 3rd. I could be wrong. The Cubs won the series. Oh, okay. Nobody cares. That was a while ago. It was only 6 years ago. Less than 6 years ago.
That's like a third of my lifespan.
All right. Shut up. All right. So I've got now 4 faculty members here. Now let's actually create an array to hold them. Right? So I want a department faculty. Faculty star dept faculty. Right? Note here that these are all faculty stars as well. Faculty star, faculty star, faculty star. Why is Joe not an array? He is an array. An array of size 1, right? So the department faculty, however, will implicitly be an array of size 4 because we're going to be keeping track of the size of this array. I'm going to make a call to malloc, and I will typecast the return value. Now in malloc, I need to tell it how many I want and how many bytes are in each. So what would that look like? It'll look very much like our create faculty right here, but instead of 1, you want 4 of them, or n of them. Remember that we can use size of on your structure to determine how many bytes are in that structure. All right, so size of faculty. That's one of them. And then if you want n of them, it's n. Why not plus 1 again? Plus 1 is only what? Only strings. Strings, strings, strings are plus 1. Okay? Okay. So I want to set the first department faculty to me. The second one to Grace, Joe, and Jane. Now, is this going to work right here? Let's try it. Well, those are all unused variables, but pay attention to this error right here. What is that thing on the left-hand side, and what is that thing on the right-hand side? The thing on the right-hand side should be easy. What is me? Faculty pointer, faculty star. What is the thing on the left-hand side? Well, department faculty is faculty star, but when I refer to a specific one using an index of 0, that basically dereferences it. So it's not a faculty, right? Department faculty is a faculty star, right? Department faculty dereferenced is faculty. Right? In other words, it's a regular old structure. So I've got to make these two things match. How do I make the thing on the right-hand side into a regular faculty structure? Remember, it's a pointer. So how do you take a pointer and turn it into a regular old variable? Dereference it. Now, technically, there is a kind of a memory leak here, but don't worry about it. Again, we're just in a testing main here. You could, there's a question online of why don't we use calc? You can, but that's, calc actually takes different arguments. It splits those two arguments up into two arguments, and then it fills it with 0 bytes. Right? It zeroes out all the bytes. It's a little bit more work, and we're not going to we're immediately going to reassign those values by initializing all those values, so there's no reason to call calc. Right? All right, Grace, Joe, and Jane. There we go. Oh, and then 2 and 3. Okay. Now I can iterate over these, right? For int I equals 0, I is less than n, I plus plus. I can go ahead and get a string representation of this, right? By calling my other function faculty to string, right? Of the ith faculty, so department faculty of I. There we go. I can print that out, printf, %s, and the line s, and then I can free up that string so I don't have any memory leaks. Right? Now, is this going to work? Oh, I've got to spell faculty correct. There we go. There we go. I've got the same problem that we just fixed, but in the other direction. Faculty to string requires what? A faculty star. And we are giving it what? Remember, department faculty sub I is just a regular old structure. So just exactly the same problem, but in reverse. How do I make this regular structure into a pointer to a structure? Ampersand. All right. There we go. Hey. All right, run it. There. Now I'm getting all of them with one loop. In fact, that seems so useful. What am I going to do? Put it in a function so you can reuse it. Void print all faculty const faculty star f, right? Faculty. All right. There we go. I didn't get rid of it, did I? Okay. Don't get rid of it. Let's try this first of all. All right. And I'm going to cut and paste, steal this code over here. There we go. All right. And instead of faculty department, it's faculty. There we go. And I return. What's the problem? Is this going to compile or not? Hopefully you can see that it's not going to compile. Why not? N, what the hell is N? So if I only pass in one faculty, right, implicitly, without a size, implicitly that's one faculty. And I was doing that all the way up here, right? Implicitly, there's only one faculty that this pointer is pointing to, because I didn't pass in the size of the array. Likewise, here, right? There's one faculty being given to this function. That's implicit. So what's implicit here is, well, there's only one faculty. So you make it explicit by saying, well, no, there are actually n faculty in this function here. All right, there we go. Print all faculty. Oh, and then I have to change it in the header file too. There we go. And now it compiles. Does it compile with the other one? Well, yes, it does, but I'm not using that function yet. So let me go ahead and get rid of this function and call my print all faculty function here. Dept faculty, and there are n of them, which I put into this variable up here for, the value for. There we go, and a.out. Now I can reuse that as much as I want. Okay? So questions on that so far? No? Okay. There is a, good point. Online it was asked, well, what, are you going to be making changes to this? Oh, yeah, we did do it const, right? Am I going to be making changes to this? No, I'm going to just be printing them out. So I'm going to put const in front of that so that you can't make changes to any of those things. Right? All right, and then to do documentation here. Prints the given array of faculty structures to the standard output using the formatting of faculty to string. And if you start getting in the habit of using proper doc style comments, you can actually link to other things. For example, I don't know if you can do it here. No, VS Code is not going to recognize this, but I wonder if it will do it. Faculties to string. No, okay. I don't know what the formatting would be for C, but in say Java doc style stuff, you can actually link to other documentation, and then you can you can direct yourself there. What else would we want? How about years of service? Since we have a hire date, right? We could design a function that computed the number of years of service. For that, that would get into, well, we'd have to find the current date, and then we'd have to subtract the year and all that stuff. And I don't want to get into that, but that's one idea, right? How old they are or something, or how many years of service they have. I don't know. You don't want to see anything? What do you have to do for this Friday? I don't remember either. You have to do airports, I think. Hack 11. Yeah, here, nope, that's hack 10. Hack 11 files. There we go. So you're given this airport. You have to design your structure. Hey, create airport, init airport, airport to string, right? Seems rather familiar, right? Everything that we've just done. But with airports, you've got now locations, latitudes, longitudes, latitudes, longitudes. Between two airports, an origin and a destination, how do you get their air distance? That sounds familiar, right? You've done that before as part of like hack 6 or 5 or something like that. And get estimated travel time. So if I gave you, say, 5 airports, you had to go from airport 1A to B to C to D to E, right? That's 1, 2, 3, 4 legs that you have to account for, 4 distances, okay? So stuff like that. With faculty, I can't really think of anything because it's just a simple toy example. Right? what is something that we could do with the ones that we've created here? Well, they look like they're in order to me already, right? Or are they? What order do they seem to be in? By last name? Okay. But what happens when you've got the same last name, Smith and Smith? Joe and Jane, are those in order? Nope. So generally when we print something by a last name, first name, we order it by last name, of course, descending alphabetically. But then if we've got ties, how do we break those ties? We look at the first name. Jane should be first. If I wanted to order by, say, NUID, are they in order now? No. What if I wanted to order by hire date here? Are they in order now? No. So that takes us to the next, and I think last, module that we'll be focusing on for the rest of the semester, searching and sorting. How do I go about sorting these things? Or just keeping it simple, if I've got an array of integers, how do I go about sorting that array of integers? And then we'll build on that to sorting structures. Okay? We have plenty of time. Any other exercises? Any questions on Hack 10, homework, anything? Otherwise, I won't do it here, but I will mention that there is an alternative, right? So, alternatives, right? We demonstrated an array of structures, right? You can also have an array of pointers to structures, right? So for example, it would look something like this. Faculty star star, right? F. I'm gonna go to the next slide. Come on, go to the next slide. There we go. Faculty star star, faculty. Right? Now, that is not a two-dimensional array of faculty, right? I mean, you can think of it like that, but that's not what it's gonna be, what it's gonna look like. Instead, it's going to look like, well, the first pointer is going to point to a structure, the first faculty. The second pointer is going to point to another faculty. The third one is going to point to another faculty, etc. And then you can also go with a hybrid approach, right? There's also a hybrid approach where you have a contiguous allocation of memory of structures and an array of pointers to them. Right? I think let me double check that if I've got it. Let's see on my iDrive here. Do I have structures array? Nope. I don't have it here. I can show it next time though if we want to see it. Otherwise, it's in the book. Right? I'm only mentioning these alternatives if you want to, because if you want to know more, see the tutorial videos and the book, right? My book. Right? I take you through these three basic ways of doing structures. The one that I showed you in class, which is the one that I recommend you go with. But then there's a more complicated way of doing it with an array of pointers to structures. And then there's a hybrid approach between the two where you can still have a contiguously allocated array of structures, but then also an array of pointers to them that allows you to then do sorting efficiently, a little bit more efficiently. If you don't care about it and you just want to do the bare, you know, I wouldn't say the bare minimum, but the basics, keep to the basics, then go with what I showed you here, and don't worry about the alternatives. Question? No.
Yeah, I was going to say, so you said that the hybrid one would make it easier for the organization? Like when it comes to like with that?
When you end up, it won't. You have to think like 2 levels deep, like Inception or something, right? Instead of thinking about structures, you have to think about pointers to structures, and then when you have, then you need to pass pointers to structures, when you go and sort it. So it is a little bit more complicated because you've got this added layer of abstraction between the two. Again, if you want to look at and see what it looks like, we have enough time here. Let me go ahead and pull up the book. It would be in chapter error handling. It's going to be in chapter 199. Oh, okay. Actually, no, sorry. The next module is recursion, so isn't this it? Oh, this might be the wrong chapter here. Ah, come on. So, conditionals, functions, error handling, encapsulation, objects. Is this it? Nope. So part 2 is what you want for C specific stuff. Functions, structures, there we go. Arrays of structures, there we go. So this is what I showed you, right? The regular old array. And the visualization of it looks something like this, right? Where rosters of 0 for now students instead of faculty. It looks like this. A student star is pointing to the first record in this contiguously allocated array of structures. Right? Each one is 40 bytes followed by 40 bytes followed by 40 bytes, just as an example. Right? A hybrid approach, a different approach would be student star star, right? Where each one is not a structure, instead it's a pointer, so maybe 8 bytes or something like that. That pointer points to an actual structure, which is 40 bytes over here. And then it's pointing to another, the second one is pointing to another structure, pointing to another structure. I depicted it here as all over the place because that's what it could be when you allocate this stuff. If you call malloc over and over and over again, there's no guarantee that it's going to be contiguous. It could be all over the place in memory. That's where the hybrid approach comes in, where you still have an array of pointers, student star star, but then each pointer points to, and then you've got the first approach here, in this column right here, where you've got a contiguously allocated array of structures, and then you simply have pointer to the first one, pointer to the second one, pointer to the third one, dot, 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 pointer to the last one. Now, why would you need that extra layer of abstraction here? It's because if you wanted to swap 2 students, right? They're out of order, and you wanted to sort them. So Jane is down here, and Joe is up here, and you need to swap them. With this approach, you're taking this 40 bytes and putting it over here, taking this 40 bytes and putting it over here, and then putting this 40 bytes over here. Right? You're copying, swapping 40 bytes every single time. Not a big deal, but if your structure was thousands of bytes, now maybe it is a big deal, right? Or a little bit more of a deal, right? But if you're taking this hybrid approach here, a structure never leaves where it was allocated to begin with. Swapping Joe and Jane now is taking these pointers, and instead of this pointer, you're swapping the pointers, which is only 8 bytes change, right? I would make this one, instead of pointing over here, I would make it point to this one down here. And then I would make this one point to that one up there to swap them effectively. Right?
In what cases would you use the second approach?
The second approach here?
Yeah.
If you don't care about fragmented memory for whatever reason, I probably wouldn't. Right? If it was a choice between the 3, I would go with this one, personally. But if I wanted to keep things simple, I would go with the first one. And then if I just wanted to be crazy one day, I would go with the second one. Right? I'm only introducing the second one here because, all right, well, this has advantages, but disadvantages. But then this third approach here has all the advantages and none of the disadvantages, but it's more complicated. I guess that's a disadvantage. Right? Again, for this course, I would recommend that you keep it simple, KISS principle, right? And go with what I just showed you here in class today. Can we look at GDB with a structure? Sure. All right. So I'm going to go ahead and go, this is a question online. Demo.c and faculty.c. Right, there we go. And let's go ahead and fire up GDB now. GDB a.out. And I will break at main, layout source, run. Right, there we go. So next. Now refresh. I imagine that you want me to say print. This is the question online. Print, say Jane. Now, if I do this, I'm just going to get a memory address, right? Because that's what she is. She is a faculty star. She is a faculty pointer. So I will go ahead and print Jane dereferenced. Hey, That looks nice, right? It's looking at everything with respect to, well, the first name here, that's the memory address of that string, but then there's the contents, Jane. Memory address of the string, contents, last name Smith. And then comma delimited list of all of the other variable values here. Very, very nice. Right? What if I wanted to report, here, we'll go ahead and go next, 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 next. And before we print all faculty using our function, let's go ahead and print all faculty with GDB. Print dept faculty at, I think that there are 4 of them. There we go. So again, that's going to be memory addresses there, right? Print dept faculty. The first one, we're probably going to get that same thing, Jane again, or me now instead, but that same formatting there. Print dept faculty at 4. Oh, wait, sorry, I can't go back. All right, dereference it, dept faculty at 4. And there we go. Well, there's several, so I had to go over a couple of pages here, but let me go ahead and print dept faculty at 4. That'll print all 4 of them, and it'll wait, pause, and ask you until you want to view the rest of them. So if I had more real estate here, a larger screen, then of course I could print them all out. But the first one here, there's Chris, there's Grace, there's Joe. Oh, they're all here, right? There are only 4 of them. There's Joe and there's Jane, and then there's the rest of Jane. So again, what did I type to do that? Print dereference dept faculty and @ sign, and there are 4 of them in there. If you only want to print the first 2, you can do that too. Right? There we go. So there you go. Correct print some of the values. Okay. Print dept faculty of 0 dot first name. Maybe if that's what you mean. There you go. Refresh. Ooh, refresh. Spell it correctly. There we go. Print dept faculty of 3 or 2. The third one, so that's going to be Jane or Joe or Jane. Yeah, Joe right there. Dot NUID. All right, there we go. 1, 2, 3, 4. Hopefully that's what you were asking for online. Are there any other questions? And why did I use the dot operator? Maybe that's the confusion. Dept faculty, what is that? It's a faculty pointer, right? So when I go dept faculty of 0, that's not a pointer anymore. That's the first one. That's a regular old structure. So I would go dot, and then whatever it is, right? Date of hire. Right. Dept faculty. Oh, print dept faculty of 0 dot date of hire. Right. Date. What is it called? Hire date, maybe? Day of hire? All right. I don't want to type anymore. Day of hire. No, it wasn't. What was it? Hire date. There we go. Hire date. There. July 1st, 2010. Well, that's it on structures. All right. So I'll make sure that you have this in the notes. But I want to motivate, and I won't put this in the notes. Instead, I'll just prompt you, right? So, challenge, right? You now, suppose you now live in a world in which you cannot use for loops, while loops, or do while loops. Right? You want to write a program to print 10, a countdown, like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, etc., 1, and then blast off. Right? But you're not allowed, this is a programming challenge, you're not allowed to write, use a for loop, You're not allowed to use a while loop or a do while loop. You can't use any loops. Right? You also can't hard code it. Right? That's the smart answer. PrintF 10, PrintF 9, PrintF 8, right? Then PrintF blast off. Right? Nope. You're not allowed to do that either. So how do you go about doing it? Decrement? But decrement would still require some sort of a loop to do it over and over and over again, right? And you would, there you would still be hard coding like 10 printf statements, right? Or 11, I guess.
Is there a way to actually like put in the time instead of this?
Oh, well, there is a sleep, right? Quit. Yes, I'll copy demo to demo.structures, just so that I still have it. I can put that in your notes later. But now let's go ahead and get rid of this. You can do something like this. Compile 1, printf, hello, and the line, and then sleep for 1 second. Right. But that's still a while loop. Implicit, yeah, where is sleep? Man, sleep. Delay. Okay. Maybe the implicit declaration will still let me do it. All right, fine. I thought it was in standard lib. Yeah.
As for the challenge.
Okay. Let's kill this because it's an infinite while loop, right? You're not allowed to do that.
I don't know if you can do this or not, but could you do a procedure that calls itself?
Okay. Do you know what that's called?
No.
All right. Well, let's try. All right. Let's go ahead and go with countdown. Countdown. Right. Int. We'll go with I here. Right. Now, let's think about this. If I've given I, if it's 10, I want to print 10. All right. So printf %d and the line I. We have enough time to do the answer to the challenge here, right? So if it's 10, it'll print 10. If it's 9, it'll print 9. When do we want it to print a special message? 0. Okay, so if I is equal to 0, instead of printing out the number, we'll printf blast off. There we go. Else, if it's not, then we'll go ahead and print out the number. All right? That's 1. Right? That's for 10, or for 9, or for 8, right? Now, I could hard code my countdown over here, right? Countdown of 10, then countdown of 9, then countdown of ... right? No, that's cheating too. Yeah.
So then would you have to place your return statement only in the ifs?
Okay.
statement?
So return, right? All right. In other words, if it's 0, then print blast off and then don't do anything else.
And then
Otherwise, if it's 10, what do we want to do? We next want to print 9, right? How do we do that? Well, we've got a function that does that for us, right?
yeah.
Countdown on I minus 1. Right? It was 10 before, now it's 9. When 9 gets called, it'll be 8, 7, 6, 5, 4, 3, 2, 1. It'll eventually get down to 0, in which case it'll blast off, and then it won't call this function anymore. Okay?
This is how assembly works.
Ah. It does?
Kinda. You have to do a decrement loop. Yeah. You have to do some funky
Oops.
stuff.
GCC demo.c. All right, let's see if it works. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. So you can write a function that calls itself. All right? Self-reference. Does anybody know what that's called in the context of coding? Let's ask Google. Recursion? What is recursion? Did you mean recursion? Yes, I did. Did you mean recursion? Yes, I did. Did you mean recursion? Yes, I did. What is recursion? It's self-reference, right? That's a little Google joke, right? It's what's an example of recursion? Recursion. Is that what? Okay. No, they didn't go with the jokey response here. Give me an example of recursion. Give me an example of recursion. Right? Self-reference. And so that's the solution, right? You can have a function call itself. Now, this looks cool, right? And it is kind of cool the first time you see it. But when you start to reflect on what this is actually doing, you think, maybe there's a better way, right? Well, what's that better way? Who would have written it like this to begin with? Nobody, right? You would have written, maybe in assembly you would have, right? What are you doing? You're simply just jumping to a previous memory location, right? The start of the same procedure or whatever, right? You're just jumping back to that memory location. Nobody would write it like this. Everybody would write a for loop or a while loop or something like that. But there are languages that do not have loop control structures. Pure functional programming languages rely on recursion de facto to do things, right? Not even Lisp, I guess maybe, or Haskell, something like that. What's another one? Those are functional programming languages. Anyway, it has its drawbacks, right? For example, what if I said countdown of -10? What's going to happen here? It's going to go forever and ever and ever. Not forever. In fact, surprisingly quick, it will segfault out. Why? This is the bad part about recursion. What am I doing to simulate a loop? Function calls function, calls function, calls function, calls function, right? I'm having stack frame on stack frame on stack frame on stack frame, right? Until what happens? It dies because your stack is full, and you try one more, and it overflows, stack overflow. In other words, I'm abusing the call stack in order to do basic computing, right? And I mean, eventually you're going to run out of that stack space. So what we're going to do on Wednesday and maybe going into next week is, what is recursion? How do you write recursion? When is it okay to use recursion? Generally, why it's bad to use recursion. And then we'll get into how you can avoid recursion using some data structures, and it's called memoization. So there's a new word for you as well. It's not memorization, it's memoization. So I don't know why, I don't know where it came from. I'm not a dictionaryologist or whatever, right? Yep, the question online is, in the recursion, the stack is keeping track of 10 variables, right? There's a variable for I for each call that you make, right? And that and we'll visualize that next time. Okay. All right. Oh, there's another question from before. If you use the hybrid approach, would you also use the arrow operator? It depends on where you are, but yes, you would use the arrow operator generally. All right. See you on Wednesday.